Hello guys, today we are going to learn about the synthesis of layered double hydroxides, which are also called LDH. Okay, so these are a class of material with useful properties that is linked with their anion exchange capabilities, and for a wide range of material application including the adsorbent, catalyst, and also it works as a support. Okay, and normally also it works as a ceramic precursor or a drug carrier or a dye carrier. Okay, now the LDH are also called as layered double hydroxide, or you can say layered material whose structure is composed of brucite, that is magnesium hydroxide, like layers stacked with interlayer anion. A part of a divalent cations in the brucite like sheet are replaced by trivalent ions giving positively charged sheets, and to compensate the positive charge anions occupying the interlayer space. So normally the chemical formula for LDH is expressed as it's a kind of big formula where we have M2 plus and M3 plus, which are divalent and trivalent cations. So you can see the formula. So normally the LDH are prepared by a lot of techniques. So LDH can be prepared by co-precipitation, hydrothermal, salt gel method. In this video, we'll be learning the co-precipitation technique. So the co-precipitation of LDH from aqueous solutions can be done by addition of a base, okay, containing divalent and trivalent metal cations by the addition of bases like NaOH or sodium bicarbonate or sometimes ammonium hydroxide. Okay, so the co-precipitation has been used basically for the preparation of LDH and their intercalation compounds. Okay, so the obtained compounds are generally having a lot of special features like high surface area, and also they are capable of removing anions or cations from the aqueous solution. So normally the advantages of the co-precipitation method are high yield, high product or high purity, and also the lack of necessity due to use organic solvent easily, which is reproducible and is low cost. So in my last video, you saw that I prepared layered double hydroxide, or you can say LDH, using the hydrothermal technique. So the first basic step is to choose the parent raw material, or you can say parent LDH, on which we are going to add our biomass or whatever material we are going to choose. So in my case, I'm going to add around, so this is around 5 gram approximately. Okay, so guys, now we will ultrasonicate the whole assortment. This is biochar in water, around 50 ml water. So these are the experimental parameters, in order to start the ultrasonication. So this is 60 amplitude and this is around half an hour, and pulse on off is around 5 seconds. Okay, we'll start ultrasonicating. So it is started. So we'll wait for around half an hour so that the whole assortment is well dispersed or well mixed. Ultrasonicated the biochar. So now I'm going to prepare the magnesium aluminum. So let's suppose if we are preparing the magnesium aluminum 1:1 LDH on the biochar. So we will add, this is 0.1 is 2.1, so it is 2.56 gram of the magnesium, and then it would be 3.75 grams of the aluminum. Okay, so this much amount I will add in the paper, and then I will transfer to a beaker. So now this is around 2.58. okay, and we have to make it up to 2.56. So now we will transfer 2.56 gram of the magnesium salt, and similarly then we will transfer 3.75 gram. Now we are going to transfer 3.75 grams of the aluminum salt. Okay, and then we would add 50 ml of the deionized water, because all the calculation that we have done here is for 100 ml of the water. Now I'm going to add 50 ml of the distilled water, deionized water. Now we are going to start stirring this mixture. So what we will do, this is our RPM. So this will shake the mixture for around 5 to 10 minutes, and then we will add our biochar mixed with the water. Now the 10 minutes has been done, so we'll transfer our biochar. Now we'll wait for the biochar to mix with the magnesium aluminum salt, and then we'll start to add the sodium hydroxide 1 molar, okay, in order to raise the pH. Now in order to check the pH, we will add a pH meter here, okay, and check. So the pH around is 3.25. so now we will add the 1 molar NaOH solution using a syringe, and that should be added in drop by drop, not all together at once. So normally it consumes around 50 to 60 or 70 ml of the NaOH. So after adding certain drops of NaOH, you can see the pH has a little bit raised up. Okay, so we'll continue adding till the pH becomes 8.5, okay, to 9. Okay, in some of the papers you can find 9 also, or 10 also, and in some of the literature you can also find that instead of using NaOH, we can also use the mixture of NaOH plus Na2CO3 also, and some of the papers you can see using ammonium hydroxide also, ammonium hydroxide. So our main concern is to raise the pH so that the co-precipitation occurs. So after raising the pH till 8.5, I will just cap the system, and then we will wait for around 24 hours, and then we'll take out the whole assortment and then centrifuge or filter it. So I'll skip this step. Okay, so we'll continue adding NaOH till the whole pH of the assortment or mixture becomes 8.5 to or 9. So pH has already become 8.5. so now I will cap the whole system and wait for 24 hours. So now I have capped the system. Also make sure you add a silicone or a kind of a glue here. Okay, now also you need to make sure I have to switch on the water so that the whole water flows. Okay, and system is constantly being cooled by the use of water. Okay, so now we'll wait for 24 hours. After 24 hours we'll take the whole assortment and try to centrifuge. So guys, this is the final step. Okay, I'm going to wash my prepared biochar LDH. Okay, so I will add water and then cap it up and try to shake the whole assortment. Okay, and then we'll centrifuge for 6 to 7 washes, and then we'll dry, and then we will centrifuge, and then we will grind, and then we'll store in the airtight container. Now you can see I have transferred these, the prepared LDH, biochar LDH, into with the water. Now I'm going to centrifuge. Okay, so now what I will do, I will try to increase the time. So I will do this for around 10 minutes. Subsequently we'll do this for more 5 or 6 turns, and at the end we'll wash our whole assortment with methanol, high purity methanol. So either we can use methanol, acetone, or ethanol also we can use. So in order to remove the you can say the lingering or the residual impurities from the prepared biochar LDH. Okay, as I said earlier, that we after the whole washing with the water and acetone or methanol, we have to dry, and then we can store it after crushing for the further usage. So guys, normally after drying, you see the magnesium aluminum LDH. Okay, this looks like this one. Okay, so guys, you can see the magnesium aluminum LDH after drying looks like this. So after this we have to crush. Okay, and then we can use it for further use.